Hello, and welcome to Chasing Leviathan, the podcast where we pursue big questions. My goal today is to listen and learn just a little bit more. As we head into our conversation, let me invite you to chase life's biggest questions with me, one episode at a time. Dr. Kevin McCain, glad to have you on the show. And if you could just tell us a little bit about how you got into philosophy and how did you get interested in this topic, understanding scientific explanation?
Well, first, PJ, thanks for having me. It's a pleasure to be here. And as with many things, the answer to the other question of how I got into philosophy is kind of a long and winding tale, but I'm happy to tell it to you. So I originally, for the longest time, thought I was going to go into law, right? So even growing up as a kid, I wanted to be an attorney and so on. And so I thought, I'm going to do law school. So when I started my undergraduate, education, I didn't care what major I took. I just kind of took, for a while, whatever major was said to be good for going to law school. So I started as a proposed political science major, took a political science class and hated it, dropped that, became an English literature major for a semester. That was okay, but dropped that. It was undeclared for a while, found out psychology was good for law school. And so I declared a psychology major. And then pretty late in the game, probably my junior year, when I completed all of my requirements for the psychology degree, except for one, I took a philosophy class. Well, I take that back. I took my second philosophy class. My first philosophy class I'd taken as a freshman or sophomore was Intro to Philosophy, which I hated and dropped because I didn't care much for the professor's style. I found it very boring. So I actually, it's kind of interesting. I've never been a student all the way through an Intro to Philosophy class. And I have no idea how well I did on my first philosophy paper because I wrote the paper for that class and dropped the class before I ever got any grades in it. As luck would have it, I went to a small state university. And so I ended up having to take that same professor for like 4 other classes once I decided to major, but that's another story. So anyway, I was in my junior year and I took a philosophy class. It was actually logic. So probably to most people, the least interesting, philosophy course. But I took that because it was recommended, hey, you should take logic classes because that can help you with the LSAT for getting into law school. I took it, really liked the professor, really liked the course, took another one and thought, well, I'm going to add a philosophy major in addition, which was kind of a pain because the degrees are 2 separate degrees at that university. So it's a bachelor's of science in psychology, bachelor of arts in philosophy. So I was like, well, I'm going to do it. And I'll stick around an extra year to finish it. Then talking with that professor who ended up being my advisor, he had a law degree. And then he kind of explained to me more of what attorneys actually do rather than my perception from television. And then I had a moral quandary, or I faced a moral quandary, which was I really wanted to go into criminal law. And then it struck me that I would really not want to have to defend someone who I thought was guilty and deserved to be punished. And on the flip side, I wouldn't want to have to prosecute someone who I thought didn't deserve to be prosecuted. And I thought this would be horrible. And then I also thought, well, I really like philosophy and I like teaching. So I decided to drop the plans for law school and go to grad school in philosophy. And so that's kind of what got me into philosophy. So I said it's kind of a long story there.
Yeah.
For this particular,
it's a good one though.
Yeah, it's kind of a winding tale. And I think for many of us that go into philosophy, you mentioned you have a master's, yours may be somewhat similar where we kind of get there eventually. For this particular topic, I've worked for quite a while now in epistemology. So the area of philosophy that deals with knowledge and what makes for good evidence, what's understanding and so on. And that's kind of my main area. But over the years, and in particular, my views in epistemology are that knowledge and rationality are intimately connected with explanation. So very roughly, the sort of theory that I defend in my, academic work is that what makes a belief rational is that it is part of the best explanation for the evidence we have, broadly construed. And this sort of book, the Understanding How Science Explains the World, gets a lot to that explanation aspect of it. And so that kind of got me to the topic. This book in particular, I worked on these sorts of issues on how explanation leads to knowledge in general and how it leads to scientific knowledge and understanding in particular. And the series editor and I had co-authored a book before he became series editor. And then he suggested to me, he said, I'd really like to have something on explanation in this series, right? So this is part of the Understanding Life series, which is a series of books aimed at a general audience, really focusing on issues in the life sciences. And most of the other titles in the series are much more narrowly focused. So things like understanding coronavirus, understanding heredity, understanding evolution versus development, that sort of thing. Well, the series editor said, it'd be nice to have a more broad entry that's on understanding, scientific explanation. And he said, I think you might be a good pick for this. Do you want to write up a proposal that we can send out for review and so on? So I said, yeah, that sounds great. So I did and got good feedback on the proposal, changed some things, and here we are.
I love it. And even as I was looking at the book, it definitely struck me as, I have some background in philosophy. And when you talk about explanation, even like hermeneutics, I understand some of the issues involved. But it seems like such a great antidote to a lot of people just misunderstanding what science does. And so, one, I'm really excited about today's interview, but also just excited about the book in general. So for our audience, one, I talked a little bit briefly before about how I've done some work in philosophy of art, philosophy of literature. And one of the things that's interesting to me about, and has always been interesting to me about literary discourse, is that it's not explanatory, right? Like when it is explanatory, it's kind of incidental. That's not the point of it. And so I'm really excited today for people to understand, like, one of the things, like, explanatory discourse exists in very different modes, right? But science is definitely one of the main ones. And so I don't know. I'm probably just a little too excited about today's interview. But yeah. So tell us a little bit about what explanation is. And even here is I'm kind of just going through the outline of your book, why it matters for science.
Yeah, that's a great question, PJ. So in general, explanation is just answering certain sorts of questions in a particular way, right? So we use explanations all the time. As you mentioned, in various contexts, they may look a bit different, but we're after the same thing. We're answering questions about why are things the way they are? How does this sort of thing occur, right? So you can think of even simple things. A classic example in the philosophy of science literature is explaining why it is that a bottle of ink fell to the floor, right? So just an explanation, someone's arm hit it, right? That's an explanation. It tells us why this happened. It even gives us a clue on how these sorts of things happen, right? So we learn from this that, if there are other objects near the edge of a table and you hit them, they're liable to fall as well. So in simplest terms, I think that's what explanation is all about. Why is something the case? How did it come to be that way? Now, that's important for us in general, just in terms of it helps us navigate the world, right? It helps us kind of predict and make plans about what we should do. If we figure out why something is this way, maybe we can do things to make it not be that way anymore. Or if we learn how to produce something or how to keep something from happening, that gives us a bit more control. Now, when it comes to science, I think one of the main epistemic goals of science is understanding. Right? We want to understand how the world is. And the way that we get understanding is through having explanations. Right? So plausibly, at least very generally, to have true understanding of some particular phenomenon, or even, maybe even more broadly, to understand just about anything, is to have in your possession the correct explanation. So what I mean by in possession is like you actually grasp it. So not in the sense of, you've written down the explanation of it and I have that in my possession, but more I've read it and have awareness of it and can appreciate it. Then I understand what's going on. And so I think that's the primary epistemic goal of science, is to have understanding. And as I argue for in the book, the vehicle by which we get scientific understanding is explanations.
Mm. Can you elaborate a little bit more on what you mean by like being in possession of?
Yes, that's a great question. So the thought being, I grasp the explanation, right? So we might say, some philosophers want to say, I know the correct explanation, so I have knowledge of it. I'm hesitant to do that, just because I think for, probably somewhat esoteric reasons, having to do with, epistemology and worries about skepticism that other people probably don't and shouldn't worry about.
Yeah.
I'm hesitant to say you have to know it, but maybe you have to have a rational belief in that explanation, right? In the parts of it, and it has to actually be true or something like that. But in loose talk, one way to get it is the correct explanation. So, for instance, if say your car isn't working right, and you understand, or excuse me, I should say this, that the problem is you have a dead battery. So in this case, you understand why the car isn't working, right? Because you know the correct explanation for why it isn't working. And so that's kind of what we mean by you possess the explanation, right? It's something that you have mental access to.
Would it be fair to say, and I think this will get into some of the section on models, that while knowledge is distinct from action, you know something if you follow through on it and the action occurs as you think it will?
Good.
Does that make sense?
Yeah, that makes sense, I think.
Like the dead battery, like it's like you like if it's the dead battery and you change it and then the car starts working again, then you did know, right?
Oh, good.
Yeah.
That's helpful.
Versus,
Very good. I think maybe what I would, a slight variation of that is what I would say is
sure,
that following through with the action confirms that you're correct, right? Gives you additional evidence, right? So you might have known it. So for instance, you might know that the battery's the problem, but be unable to change it for whatever reason. Say, I'm sick in bed and I'm like, oh, it's the battery, but I just, I can't do anything about it. It could be that I know this and I'm right, but I can't get that additional confirmation from it. So,
but if I pass that knowledge on, it could be
for someone else.
Yes. Yeah.
Right.
Yeah.
And that's one of the ways, and we can, there's differences on, how much is required for knowledge, right? So one person might say, oh, I know full well because I can reason through this. I'm aware of what the possibilities are for why the car won't start. And I know that it's not various other ones. And so I can know that it's battery. Whereas someone else might say, that's not good enough. I have to do like you mentioned, and I need to go and test it and see. And then once I do that, then I have knowledge. And that could be, right? So there, the disagreement isn't about, what's required for understanding or so on. It's a difference in terms of how much evidence do you need in order to have knowledge. One person is saying, well, the standard is here, and another person saying, no, we have to meet a higher standard. Yeah, so I could use this.
Yeah, this came up with Dr. Kevin Elliott. We were talking about values in science, and he mentioned that one of the things that's really important when we talk about values in science is how much weight we need from evidence for certain experiments because they have more ethical implications, right? Like if my car is the only way I can get to work, like that knowledge is going to be considerably more important than like some junker that, like maybe it's just sitting out in the lawn. Maybe that's Central Florida talking there, but yeah, I could definitely see. And I think that's where even we get into, you talk about different kinds of scientific explanation, right?
Mm-hmm. Right.
Do you mind listing some of the different kinds of scientific explanations? And I think that'll help people understand, one, I think this is really important because, common, especially between philosophers and like what I'd say, the average person, um, most people intuitively grasp what's an explanation, but a lot of the work you're doing is delineating those. So, what constitutes a scientific explanation, and what are those different kinds?
Good. And I think that's a great point about the average person grasping what an explanation is, because as I mentioned in the book, the difference between an everyday explanation and a scientific explanation is a difference of degree, but not kind, I think, right? So they're not different kinds of things in this broad sense.
Mm.
They have differences in terms of degree, right? So the scientific
Okay.
explanation is maybe more precise. It's maybe more generalizable, but it's the same sort of thing. We're still answering why questions and how questions. Now, that being said, there are important distinctions we can draw amongst different kinds of scientific explanations. So in the book, as I mentioned, it's part of the Understanding Life series. So I look at, in particular, this sort of distinction between historical explanations and experimental explanations. And experimental explanations, I think, are what most people think of when they think of a scientific explanation, right?
Right.
You go into the lab, you run some tests, you see what happens, and then you form an explanation about why this is what happens, right? So you put some litmus paper in a chemical, it turns a certain color, it turns red. How do you explain that? Well, it's the chemical is acidic, and then you have background information about litmus paper turns red, when it's in an acid. That's an experimental explanation, and that's what most people think of. But there may also be historical explanations where we can't run an experiment, but we can look at things that have happened. So things, in terms of geology and so on, like why is there this difference in, say, the soil, at a certain level from this other? Well, we can explain that by, say, maybe there was a meteorite impact, and that explains this sort of difference. Maybe there was some plate movement, and that's caused a certain part of the soil to move above the other. And so that's still explaining, right? Still saying why, but it's you can't test it in the lab, right? So it's not like, okay, let's just go run this test again. And so that's an important distinction. And one thing that I think it's interesting about that is it gives rise to what I think is a mistake, and that's where people think the experimental explanation is inherently better than the historical one. And I think that's incorrect for at least a couple reasons. One, in actual practice, it's hard to separate the two, right? So conceptually, I told you, and it's like, oh yeah, this is kind of easy to see the difference.
Right.
In scientific practice, it's often hard to draw that hard and fast line because people will be using historical data and so on,
Well, technically, it's all historical data, right? I mean, if you really get down to it.
That's right. If you really, that's spoken like a true philosopher.
Yeah.
Right? Because it happened in the past, it's historical. That's right. Yeah.
Yeah. And no one can do all the experiments by themselves. So you have to take even some of it on authority, right? You have to trust that even if you, like most scientists haven't met every single scientist that they use their data from. In fact, that'd be technically probably impossible. Most of the time you're going to use scientists who have been long dead. And so I think that's a great an important point. I've been laughing a little bit because, and for my listeners, they're probably tired of me bringing this up, but I grew up independent fundamental Baptist, and so when you talk about, we had a lot of creationist seminars, and one of the things that they would be very frustrated with, one of their like big claims was that you could not prove evolution by experimentation, and so I think what you're talking about is super helpful because it's like, yeah, but it's an historical explanation, and it seems to fit a lot of what's happening, right? Which, not get to that, but yeah, go ahead.
No, I think that's exactly right. I think that's kind of a profound misunderstanding of what it takes for something to be scientific or well supported. To say, well, you can't prove this via experiment, so it's not scientific. Yeah, but one, even if that were correct, that wouldn't mean that it's false, right?
Yeah, right.
There are a lot of things that are true, but we can't prove via scientific methods, right? But flip side, that can't be the standard of, show that it's true via an experiment for science, because we'd have to just get rid of large areas of what's clearly well-supported science. which seems
and what
extreme.
and that we're using to build experimental stuff on, right? Like,
Right.
and
Yeah,
then
very good point.
yeah, it goes back and forth. So talk to me a little bit about what are biological explanations. And I think you talk about here the difference between actual sequence versus robust process.
Good, good. And this is like with a lot of these, philosophers of science disagree on how important these distinctions are. So one of the reviewers for this book who actually gave me feedback is a friend of mine and a philosopher of science who thinks that some of these distinctions are not worth making. Right. Someone else.
He disagreed with you? How can you guys still be friends? I'm shocked. Yeah.
Yeah, that's right. And then, of course, one of the other reviewers is, no, you have to talk about this distinction because it's so important.
Of course.
So what do you do? But the general idea there is pretty straightforward. So an actual sequence explanation gives you information. It explains what happened by looking at the actual sequence of events, right? So the names kind of says it all there.
Right.
And so that's one sort of explanation. But a robust process explanation is different in that it doesn't necessarily look at the actual sequence, but it looks at, here's a range of things that could have happened that would have led to this same result. Does that make sense? So you kind of look at there, instead of pointing to, with the first one, you point to, this is the actual process that produced this result, which is an important kind of explanation. Whereas robust process explanations might say, here are a number of processes, any one of which would have produced the same result.
Can you give me an example?
Right, good. I mean, so like an everyday sort of example might be, so say again, let's see, how would be a good everyday example here? Let's take the car again.
Yeah.
So the car isn't starting, right? So an actual sequence is, why doesn't the car start? Well, the battery is dead. This particular feature of the battery, right? So the battery is dead because this particular, I don't know what they're called in it, but like the channel of battery acid, this particular one is too low, right? Since it is too low, that led to, it not having enough electrical charge to, get your starter going, get the motor going and everything. A robust process explanation might point out that, if this channel were too low, it wouldn't start. If this other one were too low, it wouldn't start. If this other one were too low, if the battery had a hole in it, so it gives all these different ways in which the same result would apply. That's kind of very roughly the sort of idea.
Hence the robust, yes. So yeah,
right.
It's not
There's just so many ways this would have occurred. Now, one of the ways you can see this in which I think of as a robust analysis explanation, some may disagree. There are what's sometimes called equilibrium explanations in biology. And so that's where you explain how particular initial conditions could be, all these various different initial conditions have to lead to the same result, right? So one example of this is what are known as the Fisher-Sex ratios. And so that's the Fisher-Sex ratio. That's this idea that if you look at sexually reproducing organisms, if you start with a population, whatever mixture there happens to be, whatever the ratio of male to female is in the population, doesn't matter. As long as, there's no outside force that comes in and wipes them out or whatever, after so many generations, they will reach a balance of about 50%, regardless of where you start, right? The evolutionary pressures will lead to preferences, so say you start out in the population with a higher percentage of females to males. Well, then producing male offspring will have an evolutionary advantage, right? And so those genes will be passed on more often, and you'll end up with more males being born until you get to about an equal amount where there's no longer an advantage. And what's really interesting about this is that's sort of a robust analysis explanation, right? Because it shows all these different ways you're going to end up in the same endpoint is the kind of thought. So that's a way of thinking of it.
Got it. And and you've touched on it briefly, and I'm kind of walking through your book here. Can you explain a little bit more about how historical explanations are scientific?
Oh, good. Yeah. And so they still involve the sorts of things that we typically think of in science, right? So they involve observation, empirical study, and so on. Um, I think that's enough to count as scientific to my
Okay.
mind, right? It's tricky in one sense to say, why do these count as scientific versus something else? And that's because I think we're yet to have a good answer to what's called the demarcation problem. And that's the problem of simply saying, what does it take for something to be scientific versus not scientific?
I was just about to ask.
Yeah. So that's an extremely hard question, right?
Yeah.
I have yet to see a fully satisfactory answer.
Hmm.
It is hard enough. It's such a hard problem that many philosophers of science think it can't be answered and we shouldn't even worry about it, right? Like that there isn't a good answer. And part of the issue is, some people might hear this and think, well, of course I can say what it counts, Well, I challenge you, if you come up with a good answer, see if it does both of these two things or these few things. One, gets all of the paradigm sciences to count as scientific. So biology, physics, astronomy, so on, chemistry. And two, rules out all these things that we don't want to count as scientific, like, say, astrology, right? Whatever, Sorry if anyone thinks astrology is scientific or is a science. And the problem is it's hard to do that, right? It's really hard to rule these out. If you get typically what happens is if you get or offer a criteria that's strong enough to rule out the clear cases of what we might want to call it, pseudoscience, things that try to look scientific but maybe aren't. If it's that strong, it'll also rule out things that are paradigm cases of legitimate science. If it's loose enough or weak enough to get all the paradigm cases of science in, it'll start letting in some of this other stuff, right? So you might think, initially someone might say something like the following. So when I teach philosophy of science to students, I always talk about this problem because it's such a great one. Students can grasp it immediately. And one of the things they'll say is something like, well, it's not scientific if it doesn't rely on experiments, if you can't run experiments to test it. And I say, okay, well, what about theoretical physics? Areas that are still just purely theoretical.
Right.
Do we say they're not scientific? I mean, you say, okay, well, no, maybe it's not that. They just have to say, do some empirical investigation, like make predictions about what happens in the world. Astrology does that. You are going to have a nice week this week because the planets and stars are in a certain position, right?
It is empirical.
It's empirical. It says something about the world, right? So it's really, really hard to give a good answer there. I'm inclined to say it's tricky. It's one of those sorts of things which is totally unsatisfying, where it seems like we can recognize a science when we see it.
Yes.
Recognize something's not when we see it, but we can't quite spell out why. That's something that happens a lot in philosophy.
Yeah, it does remind me, and this is, Wittgenstein's been kind of circling my brain through some of this discussion, and even as you're talking about, like, it almost sounds like we're like in a family resemblance kind of problem.
Exactly. Right.
Yeah. I mean, not necessarily a problem, for Wittgenstein, but yeah. I had talked to Catherine Malibu on about Kant's view of the transcendental, and one of the things that Kant had been working on. I'm saying like I know him or something. No, but like he
when you're chatting with Emmanuel.
Yeah. Hopefully your definition of science doesn't include like necromancy, anyways, but the one of the things that she kind of drew from it was that the split between that people often struggle with in the transcendental actually refers to the split in the sciences between biology and physical sciences, especially something like physics. And even as you're talking about the paradigmatic sciences, it sounds like you could almost come up with a definition if it didn't have to include things like biology, right?
Right.
Anything that involves things with purpose. And that's kind of like the whole point. What, like, she was doing a rereading of Kant and kind of talking about how the transcendental actually evolves over time. or technical term was epigenesis, but that the whole point was that uh, life sciences have to rely on purpose because life has purpose, whereas physics does not, right? The physical
Mm.
sciences do not. And is that often what causes this kind of problem? Like, am I tracking a little bit here,
That's a
or
good question. It it may be, although I find that the problem might be caused by something even broader.
okay?
Um, so so even things that maybe are that our explanations don't appeal to purpose in particular, but if we say, well, you can't run experiments to prove whatever theories, and so on, you have a hard time with things like astronomy, right? What experiment can we do to show that, this sort of star is going to explode in this sort of way, right? We can run tests and we have observations and we form good explanations and we come to know these things, but we're not going to reproduce, exploding stars in a lab, at least not that I'm aware of,
Yeah,
right?
hopefully not. Yeah.
Hopefully not, So the person who makes that sort of claim to rule out things like, say, astrology is also going to rule out astronomy. And it doesn't seem like that's going to quite get to it. But definitely, I mean, if you, I do think when we're looking at just the kind of classic hard sciences, which a lot of philosophy of science, when it initially got going, say 50s, and probably even earlier, like mid 20th centuries, I don't know, 40s, 50s, 60s, was really focused on physics, right? And so when you're really focused on physics, it may seem like you can give a clear answer to this. So, Karl Popper had this famous thing, it's just falsification. Can you design an experiment to test and show that it's false? That your hypothesis is false. If you can, it's scientific. If it's not, you can't. And he was really against two things. He really wanted to rule out psychoanalysis as being scientific, and he really wanted to rule out Marxism. Right. And he said, these don't cut it. They're not scientific. And then he was a big fan of Einstein. He was like, but something like relativity does. The problem is lots of things are falsifiable, right? So again, I like to use astrology, right? You can test. Your horoscope says you're going to have a great week, or you're going to come into a large amount of money. Test it. You didn't come into a large amount of money. It doesn't seem like that should make it scientific. Right. And then there's also, there's these philosophical worries that the sort of crucial experiment that Popper's talking about, where you can run a single experiment and determine that something's false, that those don't exist.
Right.
So, Pierre Duhem and Quine, they working separately, but they produced it's attributed to both of them, I guess, because they independently, what's called the Duhem-Quine thesis, is this idea that scientific testing and scientific theories and acceptance and so on is holistic, in the sense that you don't just have a theory or a hypothesis, because on their own, they won't give you any predictions, right? You have to include various auxiliary hypotheses that we don't even think about, such as this instrument can measure what I'm looking for, it's accurate, and so on. And according to the Duhem-Quine thesis, whenever you run an experiment and it yields a result that seems to conflict with your hypothesis, you can give up the hypothesis, or you can give up an auxiliary hypothesis and can maintain the hypothesis. So basically, their thought in general terms is we never test a single hypothesis in isolation. We always test this big cluster of things. And when you get an experimental result that conflicts with the cluster, that only shows you something in that large group is wrong. It doesn't tell you what. And so they worry, that the sort of critical or crucial experiment that Popper says we should do doesn't exist. Now, of course, there are philosophers who disagree with that and say there's ways to bypass what Duhem and Quine are up to, by testing various different ways. But that's kind of just, some of the idea and some of the challenges with a sort of classic response to the demarcation problem, right? Falsification doesn't seem to be enough.
Right. I mean, the idea that there's a pure experiment seems to deny our basic finitude, right? Like, we can't control for everything, and it's amazing, what could mess something up. And especially like when you think, and maybe this is an issue. Maybe this would be simple for popper to answer, but like even when you talk about a single experiment, right? Like it would have to be multiple experiments because you need to, like, repeatability is important.
Right.
Um,
Absolutely.
uh, and I'm sure that gets also into the robust versus the actual events, right? Like you'd need to run enough experiments if you think it's important to have the robust process as well. Um, so talk to us, and we've kind of gotten into this a little bit. What makes for a better or worse explanation? And we've started talking even a little bit about predictive power, but definitely interested in that.
Yeah, that's a great question. That's I think super important, and no matter what answer I give, it's going to be somewhat controversial. So I'm just going to give you the answer that I like. that I
Yeah,
think
okay,
is
that's fair.
I think that, and it's interesting too, though I should mention this. It's more or less controversial depending on who you talk to, right? So philosophers of science are more inclined, at least some of them, to think that, yeah, of course, certain things they make for better explanations. Why? Scientists seem to look for these things, produce theories that have these features, and they get things right. That's a good enough. Epistemologists are more inclined to say, well, just because they got it right doesn't mean, that's not good enough, right? We want more justification. But the sorts of things that I think of, one, like you mentioned, predictive power is a big thing, right? So if you have a theory or a hypothesis that allows you to make accurate predictions, that's a very good sign that it's on the right track, at least. Another thing is what we might call, though, explanatory power. Does it allow us to answer a lot of why questions and how questions, right? These explanatory questions. So one way to think of this is comparatively. So if we have two hypotheses, if one of them answers a whole host of explanatory questions, how and why various things happen, and the other one only answers a few, then the first has more explanatory power, and at least on that measure is a better explanation than the second, right? Because it's explaining more. Another feature is simplicity. So in terms of the simpler explanation, in general, they tend to be better. Now, simplicity, of course, which is somewhat ironic, is a very complex subject, right? There are many different forms of simplicity, and people argue about which ones count, which ones don't, which ones are important. And you can have theories that are simpler in one way, but more complex in another. So just to give an example, one sort of simplicity refers to the number of objects something posits. Okay. Another one appeals to the number of different kinds of objects something appeals to. So to take an example from the philosophy of religion, there's the fine-tuning argument. So there's an argument for God's existence that says, when we look at what the scientists tell us, the odds that there would be life in this universe are extremely low. Like, so many factors have to be just right that it's kind of mind-boggling the probability of this. It's just incredibly low. Well, one response people sometimes give is a multiverse hypothesis. So they say, yeah, but if our universe were just one of a perhaps infinite number of universes, then it's to be expected that at least some of them would be in this range, and they try to avoid the problem. I only mention that just to kind of illustrate the debate there. Sometimes people will try to appeal to simplicity on one side or the other. So the naturalist will sometimes say the multiverse hypothesis is simpler than positing God, right? Because they'll say it posits fewer kinds of things, right? Both views posit physical objects, but they'll say, but the multiverse hypothesis, that's all it posits is physical stuff. The other side, you posit physical stuff and this immaterial substance, God. On the other side, the theist will say, no, actually, this hypothesis is simpler because you, the naturalist, are positing an infinite number of things, right? And so they'll say that's way more complex. And so that, there's this fight about which kind of simplicity. Setting that aside, I actually don't think either of those kinds of simplicity are what really matter. But that's just to show you some of the complexity.
It's a great example. Yeah.
It's a nice way to get a handle on this. The sort
Right,
of
right.
simplicity I think matters is in terms of, and maybe these are related to it, but in terms of how many fundamental regularities you have to propose, right? So if you're looking at a big picture, how many brute facts do you have to accept in
Hmm.
order to do your work, right? And so I think accepting fewer is better, right? So doing more explanatory work with less stuff, in that sense, less unexplained assumptions or so on, is better than having to assume more stuff. That's kind of a rough way to characterize a kind of simplicity.
Okay, I actually had this written down, and so maybe I actually realized what I have written down is slightly different, because at first I was like, my mind went the complete opposite direction, but I'm realizing that it's slightly different. When we talk about explanatory power, oh, we were talking about simplicity. That's why. One of the
Mhm.
things for explanatory power is how big is the going back to what you said, how big is the consistent cluster,
Right.
right? And so it gives us more brute facts to work with. But simplicity, on the other hand, says we only need to accept a couple. And I'm probably just talked myself into an unnecessary dead end there. But do you understand what I'm saying? How like it's almost
Yeah,
like the
yeah.
two conflict.
No, yeah, I think you're actually hitting upon what's often a tension is explanatory power concerns how many things can we explain.
Right, right.
Simplicity, in a sense, is how few things do we have to accept without explanation, right? So, uh,
But the solution is that you can explain a lot of things by just accepting a few.
right, that's the goal. But-
Okay. Yeah,
yeah,
yeah, yeah.
yeah. Now the
Got it.
worry is often to increase your explanatory power, so to explain more things,
Right,
you have to give up someone's simplicity, right? So you have to add more
right.
complexity to account for more, and vice versa. To get to more simplicity, you might explain fewer things. And so sometimes there's a trade-off. Uh, and then, there's other explanatory virtues, but I'll just mention about the trade-off there. That's
Yeah,
the really hard question. Is
yeah,
okay, you've got all these virtues. So I mentioned explanatory power, predictive power, simplicity. I think those are the main ones. I also in the book talk about beauty,
yeah.
which some people just equate with simplicity. But
Mhm.
if you look at the work of scientists, they often treat beauty as this different thing, and they describe it differently. Sometimes they talk about it in terms of like symmetry amongst equations, or sometimes they mention this idea of this sense of inevitability. Like if anything were different in the theory, it would just all fall apart somehow, like it wouldn't work. Um, and they often will appeal to this as, why do you accept this, the theoretical folks? Because it's such a beautiful theory.
Hmm.
What's I think is pretty wild and impressive is often they end up being correct because of that, right? They're looking at just, is this a beautiful theory? And then it gets it right when we test things, right?
Yeah,
And so philosophers are, often suspicious of this because they'll say things like, why should we think the world is beautiful in this sense? However, if you look just kind of empirically minded, there's a good track record of
yeah.
when scientists follow, beauty as a guide to truth, they tend to get things right. And
Hmm.
so if you're kind of looking practically, like, the philosopher worries, well, why should we think the world is beautiful in this sense? What justification do we have? A more practically minded, philosopher or individual might say, it's getting it right. So that's good reason.
Yeah,
Um,
yeah.
you know,
Would that it reminds me of the word elegant too. Like you often hear like an
yes,
elegant theory, very similar.
yes,
Before you and you did want to talk about the trade-off, and I want to respect that. You also mentioned conservatism. And I think I know what you're going for there, but if you could explain that for our listeners.
sure. Yeah. Yeah. Thanks for mentioning that. I've got a copy of the book over here, but I didn't look through to see which ones I'm missing.
Yeah, yeah.
Conservatism is just this idea that um, where possible, it's best to kind of conserve what we already accept. And so to get a
Yeah.
handle on this, it's often helpful to compare, two hypotheses. So imagine we have two hypotheses that are equally good on all of our other measures, whatever they are. One of them requires very little to no revisions in our current accepted, corpus of scientific knowledge. The other requires radical changes. The first, in this case, the first hypothesis is much more conservative, right? So it conserves more of what's already there. And so a lot of people think, I think rightly so, that that's a virtue of the theory. If the theory requires you to give up fewer well-supported other, hypotheses and theories, that's better than, being more revisionistic. It's maybe not as exciting, but it's more likely to be true, right?
Well, and I think to me this makes a lot of sense because, and people don't, especially when I was younger, I didn't understand the value of this. But the older I've gotten, the more you have to change, the more work you have to put in, right? And if you're changing things for no other reason than just to change it, then you're doing a lot of unnecessary work, and that seems like, you know, kind of the values that we're working with there. Um,
I think that's exactly right. I mean, I think that's a very good kind of pragmatic uh, reason for doing it. Like, look, just practically, this is extra work. I think there's also an epistemic reason too, and one simple epistemic reason is our currently widely accepted theories have a whole lot of evidence in support of them. So when you go revising them, you're going up against all that evidence. So that means the evidence in support of your new theory has got to not only support that theory well, it's got to overcome all of this counter evidence in support of these theories you're wanting to get rid of. And so, in a sense, what conservatism is, I think, really getting at is just this idea of you got to look at the total evidence.
right.
And the better you fit with the total evidence, the better the theory is overall.
Hmm. Yeah, because you have more. Because generally, the more established theory is going to have more evidence and more work behind it. That makes sense. Okay. Did not think of the epistemic reason. That's very helpful. Uh, Even as you were talking about, more explanatory versus, I'm still stuck on that question, I guess. The simplicity side of things. Would a good example of this be Newtonian physics versus relativity? The idea that like obviously I would say Newton's physics are probably simpler, but they don't have as much explanatory power as, say, relativity or like Einstein's side of things.
Good, yeah. It's tricky whether Newtons are actually simpler too. I mean, I think they're simpler to grasp. So
Yeah,
that's
that's
what's
true.
confusing is they're simpler to work with, which is a kind of simplicity, but we might think that's merely a practical simplicity, right? It's how easy is it for us to work with it, can be important. I mean, if you've got two otherwise equally good theories, you might as well go with the one that's easier to work with, right?
Right.
I mean, there's a reason why we still use Newtonian mechanics to build bridges and things, right? Because
Right,
it's
right,
easier.
right.
It's not as exact, it's not as correct, but it's close enough for what we need. But another sort of simplicity gets to these epistemic dimensions, which is makes it where we have more reason to think the theory is true. And so in that case, it's at least not obvious to me that Newtonian mechanics is simpler, right? So it could be that it's simpler and yet fails on these explanatory dimensions, right? Just doesn't account for the data. Or it could be that relativity is simpler than Newtonian mechanics. It just kind of depends on, like the nitty gritty details is going to make a difference there.
Right, you're different. Yeah, and I haven't done a lot of work in simplicity, and I hadn't really thought of it until you talked about it. But yeah, simplicity is a very complex topic, which is hilarious. Um, so yeah, that phrase "close enough for what we need," I think, kind of as we wrap up here, might be really helpful. Um, what Can you explain to us the value of models and the trade-offs in relying on models?
Yeah, absolutely. So the value is, I think they're indispensable. So
Right, right. No, like you can't. Yeah,
you
yeah.
can't do anything without them. So that's very valuable. But the thought is, with models, uh, we're always looking at whether we're doing science or just to live in our everyday lives. We're trying to understand a portion of the world, right? And so world, I use that in the philosophical sense, the broad sense. I mean, like the entire universe, right? We're trying to understand a portion of it. We're never modeling everything in the world, or else we would just be dealing with the world, not a model, right?
Right,
It's
right.
the same thing. So we're always looking at a portion, but even then, there's so much complexity in the world around us. As I mentioned in the book, things that might seem, oh, this is not all that complex, are hugely complex, right? So I think I just used two examples in the book. I talk about, the coronavirus pandemic. I mean, now everyone appreciates this is hugely complex. There's so many moving
Right.
parts, so many factors as we enter yet another season of dealing with a pandemic. But even something that might seem less complex, something like the causal influences on obesity. I present this chart in the book that just shows
Right.
it's just insanely complex. And so in order for us, given our limited resources, both physical resources and just our cognitive mental resources being limited, to get a handle on things, we have to model, right? So we have to make it more manageable. So they're indispensable in that sense. But there's always trade-offs, right? Because a model of any system isn't the exact system. So it's going to have to leave out some of the information. So you might think, I like to use an example of maps, because maps are, in a sense, in this broad sense, they're a kind of model. So if you're looking at a street map, you want to figure out how to get to a restaurant. So you pull up, an app on your phone, whatever your favorite map app is, and you put it in and look, right? It's going to give you information, right? It's going to show you the streets, probably show you the distance, give you different routes. That's information about that area of the world. It's not going to tell you, most likely, mine doesn't anyway, the color of the buildings you're passing, how many people are walking by, right? These are facts about the world. It's just going to leave out. So models, in a sense, are always going to be, I think, some form of idealization. So they're not going to be fully accurate in all details. Now, there's two ways, two at least broad ways that they'll often do this. One is models will sometimes simplify by abstracting. And so that just means they'll abstract from some of the details. So your app on your phone that's showing you a map to the restaurant is just leaving out information, right? Hopefully it's not adding in any false information. It's just leaving things out, right? Because what it's trying to do is it's trying to give you an answer to a specific question. You want to know, how do I get from here to the restaurant? You don't care about, what color the buildings are. You don't care about how many pigeons are on the sidewalk, right? Unless it's an insane number of them, then you might care, but you don't care about that. You care about, how do I get there? So you can leave all that information out. Another way that models can idealize is, though, that they might falsify information. And this is really puzzling for people. Like, wait a minute, how can having false information in our model actually help our explanatory goal, help us reach our explanatory goals? Well, the reason is, by adding in some false information in a model, it can help you realize or help emphasize certain aspects or certain features of what you're looking at that are irrelevant for the question you're trying to answer, right? So a nice example of this from the biological sciences are often when biologists and philosophers of biology are looking at populations and trying to explain various things that happen with populations, they'll sometimes just add into their models that the population size is infinitely large. Now, obviously, that's false, right? They know that when they put it in. But what that does is it helps us focus in and isolate the factors that really matter. So by putting in that false value that we know is false, so we have to be careful. It's not like we're not doing a good job modeling when we have false information that we don't realize is false, right?
Right. Okay. Yeah, I'm tracking. Yes.
Intentionally false information where we go, okay, we're putting this information in because that's showing us and help emphasize to us that the size of the population is irrelevant for explaining what we want. It's some other feature. And so I think models do a good job of that. They make things more manageable. And what they do is they help us realize which factors are really important when accounting for the phenomena we're trying to explain.
Would that definition of false is interesting to me. Would that be very similar to, like, could you use the word hypothetical there?
Maybe, yeah. I would hesitate to, because hypothetical, I tend to think of as, if something's hypothetical, I might be treating it as true, even though I don't know whether it's true or not. So I might actually be agnostic about it and then treat it as hypothetically true. Whereas in this case, I know it's false, but I'm plugging it in anyway. Yeah.
Gotcha. That's really interesting. Well, I want to be respectful of your time. Dr. Kevin McCain, it has been an absolute pleasure to have you on. What's one thing that you would leave our listeners with from your book? What's one big takeaway that you think is really important for the person listening?
Oh, that's a great question. I think the biggest takeaway that I would hope people get, and this is something that I try to press in other work as well, it's kind of a big thing for me, is for people to realize, if they read the book, or even if not, if they just listen to this and decide, I got all I need from the book. The big thing to get out of this is that we shouldn't expect science to give us absolute certainty about things, right? It's a mistake, I think, probably one of the biggest mistakes is people thinking if a particular theory or hypothesis doesn't give us absolute certainty about why something happens or how it happens, then it's not real science or it's bad science or something like that. That's just false, right? No scientific theory can do that. If you're looking for that, you're never going to find it, right? So what I would really urge people to do is to think about what we want from scientific theories and hypotheses are things that are well supported by the evidence. Looking for certainty or expecting a theory or hypothesis to explain everything is just asking for too much from anything. No scientific theory can or does do that, right? And so that would be the big thing I would hope people would get is, we have to learn to deal with uncertainty. And so the biggest thing we can do is figure out, okay, we're never going to be certain, but how do we evaluate the evidence so that it's still what's reasonable for us to believe and what's not? Because I would also emphasize the fact that we can never be absolutely certain doesn't by any means mean anything goes, right? There are still theories that it's rational to accept and theories that it's not rational to accept. And that all comes down to the evidence.
Yeah. And there's definitely theories that will help you live your life better and theories that will not help you live your life better.
Right.
Yeah.
That's exactly right. Some theory, if you follow certain theories, you will not live a very long life.
Thank you again. And it's been a real pleasure.
Yeah. Thank you for having me. This has been great.